Okay, so we went from question 9 to apparently question 11. I'm not quite sure how that happened, but anyways. So backside, 11, in the chart below, summarize how the reaction will shift based on increasing or decreasing the listed variable. So concentration. So if we add, this is another way, by increasing concentration, that means we're going to add something. Okay, and so we know that it's going to shift away. Another way of saying it is it's going to shift across the arrow. Okay, decreasing the concentration, that's the same thing as taking. So you take it away or lower the amount, right? And we said that take equals to shift towards. Okay, or on the same side of the arrow. Okay, so in other words, if I had A plus B is at equilibrium with C plus D, and the question said you take or you're going to remove substance A, what I suggest you do is find substance A in the reaction, so I'd find it here, put a little minus sign next to it so you know, okay, I'm taking it, it's being removed, right? And then you can recognize, okay, A is on the left side of the arrow, I'm taking it, so it's going to shift towards this side. Well, it's on the left side, so in this case, it would shift to the left. Okay, let's jump down here. I want to do pressure last. So we're going to do temperature next. So whenever you have a change in temperature, whether they tell you they're increasing temp or decreasing temp, okay, before you can do that, you have to determine whether it's exothermic or endothermic. And you're going to tell that by the delta H. So if the delta H is negative, it's exothermic. If the delta H is positive, it's endothermic. Okay, so what does that mean? Well, that's going to tell us which side of the reaction the heat is on. Okay, so if it's exothermic, that means that the heat is on the right of the arrows. If it's endothermic, that means the heat is on the left of the arrows. In other words, exothermic things release heat, so heat is going to be a product. Endothermic reactions absorb heat, so heat is going to be a reactant. Okay? Then, from then on, it follows the same rule as concentration. Okay? So if you add, it shifts away. If you take, it shifts towards. So in this case, heat is on the right, so if we add, it's going to shift left. Okay? And if heat is on the right, and you decrease or take away heat, it's going to shift towards the right where the heat is, so it'll shift that way. Okay? Endothermic reactions are the opposite, so heat's going to be on the left, so if we add, it's going to shift to the right, and if we take, it's going to shift to the left. Okay? Finally, pressure. The thing about pressure is you need to know it only applies to gases. Okay, so any substance in the reaction that it is a gas, it will be affected. Okay, if it's a solid, a liquid, or aqueous, so if it has an S, an L, or an AQ, it is not affected by pressure. Okay, so if we increase pressure, it is going to decrease the number of gas particles, molecules, moles, whatever you want to call it. Okay. On the flip side, if we decrease pressure, it's going to increase number of gas. Okay, and we'll see that in the next example, how exactly that works. But the idea here is if you increase pressure, it decreases the number of gases. And if you decrease pressure, it increases the number of gas. So it's an inverse relationship. Raise one, it lowers the other. So we'll look at example 12 here. It says, predict the effect of each of the following indicated in the equilibrium system. So you have this reaction. Notice there's a delta H over here. Okay, before we move on to the questions, let's deal with this delta H. Let's see what I was talking about up here. So in this case, delta H is negative 200. We said that negative delta H means it's exothermic. So that means that we could add on the right-hand side plus heat. It's an exothermic reaction, so heat is a product. Okay, we're going to need this in a little bit, so we'll just leave that there. Okay, so A says we're going to add chlorine. So what I do is I look at the reaction, I find chlorine, it's right here, okay? So chlorine is on the right side of the arrow, we're adding it, adding means we shift away, so it's on the right side, if we shift away, we're shifting left, okay? So we'd say it shifts left, or we could say that it favors the reverse reaction, same thing. Okay. Now if we remove hydrochloric, let's find hydrochloric in the reaction. It's right here on the left-hand side. There's hydrochloric, right? So if we remove hydrochloric, we said if you take or remove, it's going to shift towards. So hydrochloric is on the left side of the arrow, so it's going to shift towards the left side. Okay, meaning the reaction to the left is going to speed up, which again, if the left reaction speeds up, that means you're favoring the reverse reaction. Okay. Now pressure, we said, only affects gases. So if we look at this, notice here's a gas, there's a gas, there's a gas, and there's a gas. So they're all gases. Heat doesn't count, it's not a gas. Okay? If chlorine was a solid or a liquid, we would ignore it. But in this case, everything's a gas. So next step is, once we've identified what the gases are, you look at each gas individually. So hydrochloric gas, look at its coefficient. It's 4. Okay? The coefficient of oxygen here is 1. It's the number isn't in front of it. You're looking for the coefficient, the big number in front. We don't put a 1. It's the only coefficient we don't write. So we have a 4 and a 1. So if we add those together, that means the number of coefficients, the number of gases, gas molecules or moles on the left is equal to 5. Okay? On the right-hand side, we have a coefficient of 2 for the water and a coefficient of 2 for the chlorine. So that means we have 4 moles or 4 molecules of gas on the right-hand side. So 5 versus 4. We're increasing pressure, right? So we set up here, if we increase pressure, it's going to decrease the number of gas particles. So when we look at this, notice that the left side has 5 moles of gas or 5 molecules of gas. The right side has 4. So it's going to shift to the right, the side that has the least. So right, or we'd call that the forward reaction. Okay, and then the last part of this question says decrease the temp. That's just like taking, which is going to shift towards. So this is why we found the delta H. We said it was negative, so heat was on the right. So if we decrease the temperature, we're taking away heat. It's going to shift towards the right because heat's on the right. So it's right or forward. Okay, so the key to these problems is, remember, go through the steps of pressure, identifying what the gases are and adding the coefficients. And then remember, it's inverse, raise the pressure, lower the number of gas particles. And then the other part to this is you got to remember add equals away and take equals towards.